So just a quick follow-up video to the weight and mass video I did. Now, in that video we talked a lot about gravity. We talked a lot about gravitational field strength. And I just wanted to clear up a couple of misconceptions that people might have about gravity. I'm going to start by asking a question. If you go to the moon, let's imagine you go to the moon and you take with you a football, okay? And you drop that football, or you just let go of it if you're standing on the surface of the moon and you just let go of the football. Yeah, what's going to happen to the football? Will the football, A, move to the surface of the moon? Will it B, float there in space and do nothing? Or will it C, fly off into space? A lot of people, when asked that question, they'll say, oh, it will just float there. It will just float. It will fly off into space. And they always give the same reason. They say, oh, the moon hasn't got any gravity, or there isn't any gravity in space. Well, there is gravity in space. There's gravity. Everything that has mass has gravity, okay? Now, if you are on the surface of the moon has mass, so it has gravity. It has significantly less gravity than the Earth does, but it still has gravity. Yeah, so if you drop a football on the surface of the moon, it will drop to the surface of the moon. Even the very smallest things have gravity, and this is what I wanted to show you in this video. I wanted to show you a football, and if I put another football about a metre away from it, what's going to happen? Yeah? Do you think that they're just going to stay there in space? Yeah? Well, I've just told you that everything has gravity, including footballs. Yeah? They have mass, so they have gravity. So if I stick them together like this in space, what's going to happen? Well, let's have a look. So it's going to take a long time, yeah, but you can see that it is moving. Yeah, the footballs are moving, and they are moving together. Yeah. Granted, it's taking a very long time. This is speeded up a bit, so we've just gone past 1 day, but the footballs are going to be attracted to each other gravitationally, despite the fact that there's no planets, there's nothing nearby. Yeah, but the two footballs are going to attract each other. I'm not sure what's happened there. They're not going to swallow each other like that, but they will just sort of stick together eventually after a while. Granted, it takes 2 days for them to come together, but they will come together. Yeah? Something a bit more interesting. So let's look at something even bigger. So if you look at the really big thing, let's talk about two galaxies colliding. Yeah? If you have a look at this, I've got this one here is going to be two galaxies. This is the Andromeda Galaxy and the Milky Way. I'm not sure which is which, to be honest. Oh, this is okay. So this is the Milky Way on the bottom, and then the Andromeda Galaxy on the top. Eventually, these two galaxies are actually colliding. We're in the Milky Way, and we can see that the Andromeda Galaxy is going to collide with us in a few million years' time, and it's going to look amazing when it happens. Yeah, the night sky on Earth will be incredible. I mean, the Earth might not be around because the sun will have swallowed it by then, but it will look cool. Yeah, and this is what you'll see. You'll see the two. Well, you won't see it because you'll be part of the galaxy, but you'll see the Andromeda Galaxy coming towards you, and the stars in the sky will change, and over the course of millions of years, but it will be amazing, basically. It's very unlikely in this event that actually any of the stars themselves will collide. If you think about it, there are literally light years between all of the stars in both of the galaxies. Yeah, light years. So there's almost entirely empty space. So it's unlikely that any of the stars will actually collide. They'll just gravitationally interact like this. Yeah. Stars might get flung off into space, clusters of stars might get flung off into space. Some of them might concentrate in the middle in this, where you've got this bright patch. But every single one of these little dashes of light is another star. There's literally billions in both of the galaxies, and they will combine like this, yeah? Gravitationally interacting. So everything has gravity, yeah? From the smallest things to the footballs to the biggest galaxies. That's what keeps things together. That's what keeps galaxies together. Yeah, that's what keeps Earth in orbit around the sun's gravity. That's what keeps the moon in orbit around the Earth's gravity. That's why we were able to land people on the moon, because the moon has gravity, it can drag the spacecraft back down to it so that we can land on it. Yeah? But anyway, I thought that would be a nice little follow-up video to my weight and mass video, and this is a pretty cool looking simulation of two galaxies colliding. Alright, see you in the next video.